Hello.
Good
Hello.
morning, sir.
மணிகண்டன்.
Sir, கேக்குதுங்களா?
மேடம் சார் வந்துட்டாரா?
மணிகண்டன்
Hello.
sir.
Can you hear me?
Hello, sir.
Yeah, good morning.
Yes,
கேக்குதா?
sir. Yes, sir. Join பண்ணிட்டாங்க. Sir, join பண்ணிட்டாங்க. Yes, sir. Yes, sir.
ஜாயின் பண்ணிட்டாங்க. நம்ம நாய்ஸ் இருக்கு பாருங்க. ஹலோ.
Yes, sir.
Sir, join பண்ணியாச்சு sir. சதீஷ் sir. Good morning sir.
Sir, join பண்ணிட்டாங்க. Vinita ma'am.
Hello.
Hello.
Yeah, ma'am.
Ready
Yeah, good.
ஆங்க.
Yeah, good.
Sir, we'll
Good
start
morning,
at
sir.
11 o'clock. Sir, shall we start at 11 o'clock, sir?
Sure. Hello. Hello.
Hello.
Yes, sir.
Shall we start, sir?
Yeah. Please start.
Okay. Vinita ma'am.
Sorry, sir.
Hello. Vinita ma'am.
Yes, ma'am.
Hello. Yes, ma'am. Cyrus,
Yeah, please.
ma'am. We'll start.
Yeah, please start, ma'am.
Good morning, ladies and gentlemen. I welcome every one of you for the day one session of the 3-day webinar on emerging trends and opportunities in computer science and engineering, organized by the Department of Computer Science and Engineering, Perry Institute of Technology. Gaining knowledge is the first step to wisdom, and sharing it is the first step to humanity, and it creates a lasting legacy. The 3-day webinar has been organized into knowledge sharing by experts. I would like to extend a warm welcome to our respected chairman, Mr. Saravanan Periswamy, and Mr. respected COO, Mr. Veeraraj, who is absent here for this event. I feel honored in welcoming our today's speaker, Dr. T.V. Gopal, Professor, Department of Computer Science and Engineering, Anna University, Chennai. I am glad to welcome our beloved principal, Dr. R. Palsam Kennedy, respected Vice Principal, Mr. B. Magesh, Head of the Department of CSE, Ms. K. Varalakshmi, heads of the various departments of Perry Institute of Technology, and my dear colleagues. More importantly, I am happy in welcoming the knowledge-seeking faculty and student participants from various prestigious institutions all over the nation who are connected with us through Google Meet and YouTube. With this formal note of welcome, I am privileged to invite our respected principal, Dr. R. Paulson Kennedy, to introduce the speaker of the day, Dr. T.V. Gopal, to the participants.
Okay, thank you, Ms. Vinita. Very good
Thank
morning.
you,
Is
sir.
it audible now? Is it audible?
Morning, sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
Yeah,
It is audible,
very
sir.
good morning. Very good morning to one and all who have joined in this webinar.
Yes, sir. Morning, sir.
Very good morning. Some disturb,
Sir, can you hear my
some
voice?
some disturbance is there. Somebody is talking again. Please hold it. Hello.
I request the participants to mute yourself.
Yes. Okay. Very good morning. Respected Chief Guest of the day, Dr. T.V. Gopal, Professor in the Department of Computer Science, TNT Campus, Anna University. Most respected Chairman of the institution, Sri Saravanan Perisami, sir. COO in absentia, Vice Principal Mr. Magesh, Head of the Department, Ms. Varalakshmi, faculty members, and my dear participants. Very pleasant morning to one and all who have joined in this webinar. Dr. T.V. Gopal obtained his BE Electronics and Communication Engineering from Osmania University, Hyderabad in the year 1985. He got his MTech in Computer Science from Hyderabad Central University in the year 1987. He was awarded PhD in the area of distributed operating system in the year 1998 by Anna University. From then on, he is serving in the Anna University. He currently serves as a professor in the Department of Computer Science Engineering in Guindy campus. Dr.
I
T.V.
think
Gopal,
that's enough, Dr. Paulson.
yeah, I'll brief two more lines, sir.
Okay.
He has served as honorary chief editor for the CSS Communication, a monthly publication of Computer Society of India. He is an expert member of editorial advisory board of the International Journal Information Ethics. Dr. Gopal has published 75 research papers and co-authored 54 papers. He has authored 4 books and co-edited 5 conference proceedings. Under his guidance, 4 members have been awarded doctoral degrees and 3 more pursuing now. In 2000, the then Chief Minister of Tamil Nadu, Dr. Kalanjar Karunanidhi, honored him in his chamber for the preparation of computer science textbooks for plus 1, plus 2 students of Government of Tamil Nadu. He has also been recognized by Dr. APJ Abdul Kalam in his book, A Manifesto for Change. He is my mentor and group. Such an eminent and elegant professor with us today to present webinar in the topic of fresh software outcomes in the design of distributed applications and the webinar series of emerging trends and opportunities in computer science engineering. It gives me an immense pleasure to extend a warm welcome to you, sir. Welcome you one and all in this webinar. I hope this webinar is going to be wonderful and useful to all the participants. Welcome you all. Now over to Dr. TV Gopal, sir. Thank you.
Very nice, and thanks for a nice welcome. Anita has been very nice introducing me, and I must thank Dr.
Yes, sir.
Paulson, the principal of Perry.
Yes, sir.
But then I do remember all those lively interactions that I've had with Mr. Saravanan Periyasamy on my
Yes,
on the earlier occasions. We
Yes,
have
sir.
been saying all along that today software is permeating across all disciplines. It is now not only the quality of life, it is the life itself. Software is impacting the life itself. We have no other technology that can be called something which is a parallel to software. The intention is not to compare the field of software with any other engineering disciplines. Neither it is to trigger off the old debates saying that is it a science, is it a art, what is it? essentially we know for sure that it is high time that we move from the idea of looking at software as something which is an intellectually challenging puzzle, which when one person solves, all that is necessary is to express it as a set of instructions which can be carried out by a machine. How that machine looks, what is that machine requesting in terms of expression or demanding, can it understand, does it have intelligence? These are all even more difficult questions. We began by saying that this is a puzzle that is challenging me, and I'm absolutely sure that once it is solved, a lot of people may want to jump in to try to come up with better solutions. From those simple beginnings of solving a puzzle, putting it in terms of a set of instructions that can be carried out by a machine. What is that machine? In what form it is? Who will make that machine? All that we'll see later. Everything happened. The puzzles were getting solved. The machines came. Then we started saying that we should now give this exercise a nicer term. We started saying that it's not really a problem, but what we are attempting to do as our problem is a program. What we are writing as a set of instructions should be a program, and that program should in all way fit into that machine, and we should be able to go ahead using that machine saying that this is a solution. Having said this, no, I would like to share it from my screen. Can I share it from my screen rather than the Perry screen?
Yes, sir.
So I would rather set it to my screen. And
Yeah, yes, sir.
presenting. Okay? Very good. I suppose you can still share. So what is the concern here? The concern here is that when we were doing our program, we could not really serve many people, and we know for sure that the program is not going to be having that complexity that is desirable to solve problems even during the 70s. These are all nice programs, good ideas, good solutions if you want to say. However, we could not scale it up. Let's say 71, for example, Unix was a roaring success, but the entire decade was a black decade. Nothing much happened at that scale. So what we did was we said it is not writing a program, finding out what went wrong. We should have a way of writing up the set of instructions in a manner where we anticipate what can go wrong. So it is not a puzzle, it is not a problem, it is not a program, it is software. That is a definition that arrived in 1968, 69, and we said that since there are too many possibilities, we should have some engineering incorporated in the way we are explaining what we want to do as software. That is becoming software engineering. This was known to us, let's say 68, 69, definitely we had the definition in place. So we are not solving a puzzle, we are not solving a problem, we are focusing on writing a program to be executed on the machine without anybody else. The machine can start and come to a halt, which we have already defined. At least one person has defined where to start, where to stop. That's a program. Program will let you know how to fit it into your memory, how to fit it into the bus cycles, register sizes, all that it will tell. Good program engineering has been happening. However, what's the concern with the program? For any given input sequence, you should get an expected output sequence. If it is not coming, there is a bug. We cannot live in that context because it is now no more quality of life, but it is the very life itself. We cannot say, oops, I lost a few lives because there is a bug. It has happened. Many disasters have happened. So what we did was we took recourse to the definition of software and software engineering. And now what is the context in which we are? Life. It is at a much faster pace. We do not have the time to regret. We simply do not have time to regret. 1 week of regret window is an ocean of a time. How quickly can you anticipate what can go wrong? It's today software engineering is a challenge because you are expected to anticipate what can go wrong and prepare for that now before the first line of code has happened. That's the first distinction we should make. It is not that we write some software and debug. No, we write a software with an intention of anticipating what can go wrong and prevent it. Otherwise, we can't save lives, we cannot impact lives. It's at a much faster pace, mind boggling range of technologies. Today, there is no single course, there is no single expert who can tell all these technologies are known to a group or an institution. Every day, we come across a new technology. The World Wide Web context is completely different. We are not even sure what's happening next door, even if we are seeing visibly. Globalization, it's an imperative thing. We cannot work in isolation. No machine is an island. When it is an island, it is not delivering the desired results. We had computers working as islands. We quickly got onto the networking world to make them do better, to make them serve the organization, the people better. Increased diversity, multi stakeholders, workforce is different, customers are different. It's not only the customers, but also the customers' customers. Clients are demanding faster, lower cost, and better quality. Please remember what Goss has said. I have had my results for a long time, but I do not yet know how I am to arrive at them. That's a nice statement which Goss said, the prince of mathematics, prince amongst mathematicians who taught us how to live in a statistical world. I have had my results for a long time, but I do not yet know how I am to arrive at them. So we have to somehow find a method of pushing all these things into a manner where we have defined what is called software engineering. The very first world view was a linear view. We should progress from step 1 to step n. It should have if then else or either or. It should have a correct beginning. We should know clearly what is right or what is wrong. We should have a good control. We should have predictability. Predictability is something which we have always wanted in the field of software engineering. In the process, what we ended up doing was we became completely sequential as thinkers. As people who have been thinking, we have become completely sequential, and that is our strength. Am I visible and audible? Somebody?
Yes, sir. Yes, sir.
And
Yes, sir. Yes, sir.
yeah, and the PowerPoint is visible? Okay, yes.
Yes, sir.
Good.
Yes, sir. Yes, sir.
We have become completely sequential. You please give me where to start, where to end. I will follow step by step, step by step, step by step from step 1 to step 10. I can follow, the machine also can follow. So we have become completely machine oriented. What the machine is dictating, we want to do first. In a way, we were able to create some bright sparks, good technologists who can understand that this is what is the meaning of computing. Before writing the first line of program, we should understand what is computing. We should teach computing first, then we should tell them this is the way you have to program. A good example of this sequential thinking is a nice picture here. You have to locate where A is. The first step is called A. And fly kite. Open window, A, fly kite. It should be somewhere near the window. So this is how the program looks as an image. And now I don't know why I'm no longer presenting. I'll present it again. So what has happened is it's a simple way of looking at it. A, where is A? It is here. You have to find out. This is the way in which our programs were happening. You have to start here. Where to start? A, fly kite. B, string. B is the string. C, once you pull the string, the window is lifted, allowing moths to come. That is, insects will come to escape and eat red flannel shirt. F is a flannel shirt. As the weight of the shirt becomes less, the shoe in G will step on the switch H, which heats an electric iron and burns holes in the pants. You get a smoke. The smoke enters the tree, smoking out opossum which jumps into a basket because the smoke doesn't make that opossum, this animal M, sleep happily in the trunk of the tree. It will jump into the basket. it pulls a rope and lifting the cage P, allowing the woodpecker to chew the wood from the pencil, exposing the lead. Emergency knife is always handy in case opossum or the woodpecker gets sick and can't work. What is this exercise doing? Sharpening the pencil. We are doing too much of interdisciplinarity in this picture. If you can trace, go back, look at the PowerPoint slide which is there with your institution, see how to trace from A to R. All this exercise is to make the pencil sharp by the woodpecker that knows how to chew the wood. So much of interdisciplinarity is always there, and a standby knife is there if the woodpecker falls sick or the animal falls sick. So in the middle, we have had two live things operated because of the moths coming in. There are many ways of explaining this. Today, we are in this context. Can you explain this in a manner where multiple disciplines come together in some form and format of a machine, where when we start at A, we end up exactly with a sharp pencil? Is another way of doing the things. Now, let's not be scared. What I want to illustrate here is that it is one thing to have only the things, inanimate things, machines of different forms. It is a completely different exercise to have life forms. What happens if the moths don't come? We are anticipating that the moment the window is open, the moths will come. They're all live insects. If they don't come, what will you do? If the opossum, which is the animal here, M, falls sick, what will you do? Is there any alternative? If the woodpecker falls sick, what will you do? Or it vanishes, it flies away as soon as the cage is there. Life is unpredictable. It's not a machine where we have designed and we can start from one place and say that we'll definitely end at another place. So whenever you are bringing life forms into the loop, we are having difficulties. So what was our first solution? Please don't talk about life forms. Talk more and more about machine. The more closer you get to the machine, the better it is. We will at least ensure that something is happening and then hopefully arrive at right or wrong. But we are not able to be so conclusive. Right or wrong is a difficult question. Most of the times we are telling that whatever we wrote sequentially is working. So we said this is very, very restrictive. If the machines are dragging us into the machine and we are not able to come out of it, there is no question of people dominating the machine. The machine will always keep riding us. We need to ride on the machine, the technology. So we moved over to the next. We said instead of bogging ourselves only with a sequential way of thinking, step 1, step 2, step 3, step 4, step 5, what happens if we become systemic? That is, we should be conscious that outside of this step of the sequence of steps, there are other things, related things that are happening. How much of systems can happen? Now, the first view took us towards the machine and a focus on applications. The second view brought us the nice idea called systems, which were dormant. We know that all people who are writing applications will have certain common considerations, certain common problems. We will find out what are all the common things which many people want to solve. Write that common thing once, put it in the machine. It will occupy some memory, it will take some time, but it is well worth it because so many people will save a lot of time and we develop things faster. But then what is necessary now? In the case of systems, we should clearly tell that this is X program, this is Y program, this is a part of some other program. We should know how to compare which process will take more time. We talked about scheduling, we talked about memory, we talked about moving a job from one place to another place. We should now have a tighter control on what is happening outside of this sequence of statements. For executing only the sequence of statements, a microprocessor is enough. I can feed the code, start from the end, press start button, everything will be over. But then we are doing too many things, a lot of applications have happened. The second world view brought in what is called the systems. Now into this, we wanted to build what are called good user interfaces. We said that the user should not be mixed up. The system is the system is is so complex that we can't ask the user to do 3 PhDs before using the system and the machine. Already learning the machine was bigger exercise, learning computing, learning program, all this has been a challenge. It's not so easy to teach computing, not so easy to teach program. So what we did was we started talking about user interfaces. My choice is always, talk about that abstraction, which begins with high school algebra. We should know how to make it generic. Systems view demands more generalization. Sequential view is a very particular set of sequence. This is what I want to do. This is the sequence. This should be executed. The moment we talk systems, it is necessary to have a good mathematical foundation. An algebraic foundation is very, very helpful. It is necessary. The third world view is what we are facing now. And this has really begun to impact the life. It's a complex adaptive system. It talks about a language. By saying language, it is neither a natural language nor a programming language. It is a lingua franca, which is very difficult to be expressed in mathematics. We don't yet have a mathematical expression outside of telling that some foundation courses are necessary to understand. Wherever I am talking about language, first view language, second view language, third view language, it is neither indicating a natural language nor it is a language which is like any other programming language which you might have heard of. It is the lingua franca where the terms and terminology reflect interconnectedness, nonlinearity, dynamic, unpredictability, emergence, self-organizing, making us really believe that the terms which were not native to computing, native to computer science, are now impacting us. Complex adaptive systems. From a linear program to systems and now to complex adaptive systems is a phenomenal progress in less than 30 to 40 years. And we are talking about a language that is completely known to all other engineering disciplines. And unless we talk this language today, we cannot interoperate with other engineering disciplines. Even if we want to do a small sequential exercise, it becomes very difficult. Of late, we are not writing many programs from the scratch. They're all there. Boeing 787 code. Please expand this. Large code bases are always available. All that you are doing is reuse those code bases. Several years back, we have been interacting with Microsoft. They were running a regular competition. They come, they are there over a weekend, 48 hours. They are with the university. Mrityunjay Bhadaria is a good friend of mine who was visiting us. They give some code pieces. Pieces of code are all available. Whoever is participating can study these pieces of code, put them together in a manner where they can come up with a prize-winning combination of the existing code pieces. We are not likely to develop code from the scratch. Reuse is the order of the day. How that reuse happens, whether it is happening from a single paradigm or multiple paradigms, whether we are talking about a single language or multiple languages, these are not the concerns. They were all taboos once upon a time. If you are doing C programming, you do only C programming. If you are talking about object-oriented paradigm, you talk only about object-oriented paradigm. Nothing else can come in. It should be as pure as that. Today, it is not the case. We came up with the idea called package. Java is full of packages. And what we are talking about is the fact that we are not likely, we are not.
Excuse me,
Yes.
sir. Sorry for the interruption. Sir, your voice is little low, sir. Can you able to adjust the speaker wire? A few of the participants are complaining.
Adjust the what? Microphone.
Uh, yeah, yes, sir.
Full volume. Let me see.
Yes, sir. Yeah.
Is that fine now? No, it is zero volume maybe. Just check.
Yes, sir.
Very good. It's full volume.
Yeah, okay.
Okay.
Sir. Please adjust the speaker. Yeah, okay, fine.
Okay, is it fine? So we are.
Is it audible, participants?
Yes, sir.
Okay.
Okay, fine, sir. Thank you.
Good. So what we have been talking about is the fact that we are not likely to build code from the scratch. There are good pieces of code. People have been contributing first class code everywhere out of their interest in programming. If only we know how to tie them up, we produce larger pieces of software which will do more for us. So we have talked about putting together. Today it's an in thing. We need to talk about multi-paradigm. We need to talk about multiple languages. Way back in 86, 87, we were able to connect Fortran 77 libraries to C programming. Something like that will have to happen. We need to talk about interlinking packages written for some exercise and then build much better quality code. Today, projects are balancing acts: quality and scope, timing and schedule, budgeted costs. It's a bumpy road of reality where we may have some precedence structures, we may have some statistical variations, but essentially the human behavior. It's becoming exceedingly difficult to balance out all these things. The picture is nice. It's always a bumpy road to reality because our reality is far away from the context. Most of the times we are away from the context where the problem has occurred. Now, all this expressed in the business context is the fact that we have multiple stakeholders, we'll have multiple concerns. We have a maintainer, we have an end user, we have a customer, we have a sales representative, development manager, developer, systems administration. What are we talking about? Functionality, price, development costs, on-time delivery, performance, stability and maintainability, ease of use, ease of debugging, modifiability, testability, traceability, structure and dependency between components, ease of installation, ease of integration. Integration is a very difficult idea, but we have to do it. Therefore, what is it that we understand now is that software, which was there even 10 years back, the term is the same, but the dynamics are completely different. We have to fit whatever we have been doing into a range of dynamics which are so complex. They evolve and we should adapt. Otherwise, we are not likely to progress. So it is a totally different idea, and therefore what we are talking about, this is a very difficult concept again. Enterprise application integration. Everywhere there are applications. A lot of people have developed applications. As I mentioned, we have been talking about code base, we have been existing code bases, we have been talking about so many things. Enterprise application integration, that is essential. And what are the technologies we are talking about? Just give me 1 minute. So we need to definitely, sorry for the interrupt, there was some noise here. And enterprise application integration, that is going to be very tough. We have built pieces of code, we have built wonderfully working applications. We don't even know where they are working most of the times. How to put them together is the number one challenge for us. We have been talking per se that they are all over the world. Some of these technologies that you are seeing on the slide are there in our books, still textbook material. We are still talking about it, Corba, Com, DCOM, but all of them are likely to vanish very soon. Enterprise Java beans, they are not the focus. The focus is cloud, grid, parallel, distributed computing tree. We are going to address problems at that level. So please go back to the slide where we have multiple code bases that are existing, how to put them together. That's the question. And what is the guarantee that when put together, they are working? So the essence of the entire exercise is the fact that we have become interdisciplinary. We have become very, very interdisciplinary in our approach, in our way of working. And what is now obvious is we need to talk about so many things simultaneously. There is no single subject, there is no single course that is addressing all these things that are absolutely essential in making software happen from, let us say, today. Qualitative analysis is there, digital divide is there, research evaluation, information technology, users information need, healthcare sciences, library environment, scientific knowledge is necessary, bibliometrics, e-government services, project management, text analysis. So we are at a point in time in 2020 that the entire field of software engineering is poised for a fantastic change. We should understand that all the tools, all online tools are built like this. If you are able to access a free Google Meet, it's because they were able to put together existing pieces of code to show that this is a working application. They are very straight. They tell that all these tools are available. Zoom is so many online tools, so many free tools are there, where they are very candid saying that we have been using pieces of code developed elsewhere. Our ingenuity is putting them together and show that this can happen. So there are nice applications like that. Plenty of things are there when we are going online. If we have managed this 4 months of a global crisis, it's largely because technology stood by us, and we are now able to tell that a large population is able to manage this technology without doing so much of study, so much of PhD. That's our success. Complex adaptive systems. Medical informatics, that's what is necessary. Information use, library management, information society, information professionals. So what is it that's talking about? It's a mind-boggling range of topics. Most of them have not been native to computing and software engineering. The terms were used, but they're not native. We need to expand the boundaries of what we have been calling as computing, what we have been calling as software engineering. Interdisciplinarity is absolutely essential. Integration, multiple paradigms, plenty of constraints. We do not know how to anticipate the constraints. Right now, there are a set of constraints. Next 15 minutes, the constraints have completely changed. Things have changed. The dynamic world is there. The constraints have completely changed. Humanities, multidisciplinary, scholarly communication, electronic books, academic libraries, open access, education, educational research, scalability, unbelievable pace. You suddenly see last 4 months how many Zoom meetings have happened. The world has taken over to online meetings. Whether the network is squeaking, whether the network will improve, those are not the constraints. But so many Zoom meetings, so many online events have been happening. How much they're in tune with what is the impact factor of that, that is secondary, we'll talk about later. But the sheer volume. Today, for example, I was watching when I logged in, there were only double-digit number of people who logged in. Very soon, in next 2 minutes, the number of people was 143, double digit to 143. The moment I logged in, I saw that we scaled to 3 digits. That's difficult. Number of users, number of machines. Imagine how many machines got connected in a span of 2 minutes, 3 minutes. How many people got connected in this meeting, in the same meeting that I'm talking about. So when I started, it was double digit numbers. Just to 20 to 30 people were there. Now it is 126 on my screen. It scaled to 140 in just about 2 to 3 minutes. It's a wonderful technology, wonderful scalability, which is what we are talking about. And what we therefore need is to understand that if we have to build evolving systems, if we have to build adaptive systems, we have to make sure that it is loosely coupled system. We cannot hope to have a centralized control. We have been talking about centralized controls, a centralized systems, a data center like thing, largely to facilitate going green. And we need to talk about scalability. The number of systems have increased, the number of users have increased. It is not the increase which is linear, it's a sudden spurt. Just in 2 minutes, we have had 100 logins, 100 machines coming in. Unimaginable 20 years back. The network used to squeak. There was no scope of bandwidth. Why is this happening? Because we are addressing at a larger scale cloud computing, grid computing, parallel computing. The problem is being addressed at a distributed computing level. What are the 8 fallacies? The network is reliable. Very difficult. We don't think so because certain dropouts were there. They are trying to reconnect. I'm able to observe that on my screen. saying that 3 people dropped out, 3 people are trying to log in. Thanks to my university administration, I have some nice interface which they have given to these meetings, and I see more on my machine. The network is reliable. It is not. It is true that fantastic research is going on in the area of computer networking even today, but it's not reliable. What is the meaning of reliability? Both the sender and the receiver know precisely what is happening to the message that has been communicated. Both should know. The sender should know, the receiver should know. Latency is zero. This is what is a fallacy. The moment you connect, it is not getting connected. Please factor at least 5 minutes for every meeting to connect. That 5 minutes of buffer time, 11 o'clock the meeting is opening, until 11:05 we cannot stabilize on the connectivity. It's not instantaneous connectivity. We hope all our future students who are listening to this lecture will ensure latency is zero. Bandwidth is infinite. It is not. We had audio problems, we had video problems. You are experiencing this. That's the reason why I made this slide. All these things are experienced by each and everyone who is attending this meeting. The network is secure, not assurable. Topology does not change. Please understand that the very nature of software is like that there is no single owner. People are giving a brand name and going ahead. Every software is equally insecure or equally secure, whichever way you look at it. We need to take a clear-minded view of what is the application, what is the criticality of the application, what is the severity ranking of a vulnerability if it is there. That is our job. That is when we talk. So the way we look at software has completely changed. Topology does not change. It's a fallacy. Our machines are always reconfigurable. In the line of machines, at least I can make a guess that at least 20 machines have come in and gone out. None of them are ours. The routers are not ours. The bridges are not ours. The protocols are not ours. And it's all software-defined networking. At least 20 machines have come in and gone out. And none of us own those machines. None of us are our machines. How do you know that? The topology has completely changed. There is no single administrator. It's just that we are having some nice people in every organization who are willing to take the brickbats, saying that, yes, I am the administrator. If something goes wrong, you please pass it on to me. That's how we build our institutes, our places. Transport cost is zero. It doesn't mean that all transport cost is reduced. It is not true. The network is homogeneous. It is not, it's heterogeneous. So what is the concern here? The concern here is that is not to put a scare in all of our minds, but then Dr. Richard Cook in 1988 addressed this very important concern. There are 18 core elements of failure in complex systems. Please understand that what is stability, we understand. The opposite of stability need not be chaos. We need to understand what is called complexity science. We need to understand what is called how to make the systems work when the stability criteria is challenged, because there are too many things that are fallacies and we are presuming that. When we are working, we are presuming. So there is an acceptable window, there's an acceptable error rate. Complex systems are intrinsically hazardous because the fallacies are obvious. 8 fallacies are hitting us even now. Even now we are hit by 8 fallacies. Catastrophe requires multiple failure. It's not correct to think that there is a single point failure. That the idea of root cause is also not really applicable. Accidents happen. Post-accident attribution to a root cause is fundamentally wrong. In summary, there are 18 different reasons why you should not blame technology. Blaming technology is an irrational search for scapegoats. Hindsight biases post-accident assessments of human performance. That is the root cause of our trouble first. The moment you bring in people, hindsight biases. All of us are wise with hindsight. After something happens, we will look back and tell, oh, it should not have happened or we should have done better. In anticipation, that is the challenge of software engineering any beyond 2020. Last 10 years, we have gotten accustomed to understanding that software until 2010 may be one. This decade, The demands on software engineering are completely different. We are talking about distributed computing from this perspective. It is not merely coordination strategies. It is not merely those nice ideas of putting together pieces of code. It is all this that I have been talking about in the last dozen slides. Safety is a characteristic of systems and not of their components. Components will be there, components may fail. How much ever careful you are with the components, we are not giving any warranty on the components. Safety is a characteristic of the system. Overall system should be safe. Please remember, the strength of the chain is always determined by the weakest link. People continuously create safety. That is all the more reason working in complex systems should be people first. It's the people, their ingenuity that continuously create safety when they are dynamic. In the dynamic systems, failure-free operations require experience with failure. If you have to make any system failure-free, you should have experienced failures. These are certain nice ideas which were spoken very nicely and very eloquent. It's a good paper. Richard I. Cook, you can search in the web. It's a landmark paper in complex systems written in 1988. Therefore, what is our next idea? The next idea is the core cause of failure which was driving software engineering: budget, schedule, quality, safety, technology, and other measures. These were always cited as what we should consider as goals of software project management, and consistently our success rate has been 36% this decade. Out of every 100 projects we are attempting, only 36% of projects are successful. What are the reasons? Budget, safety, schedule, quality, technology, and other measures. Therefore, we said the software process definition cannot be simply stemming from business requirements, technology. We should make it happen in a manner where it is organizational. The primary processes, organizational processes, supporting processes. So it is not something natively coming from, even though software engineering is the exercise that we are contemplating, everything is not coming entirely from the software engineering domain. By definition, the boundaries have expanded. By definition, we are talking about an interdisciplinarity. By definition, we are talking about multiple disciplines coming together, and we cannot produce a PhD in all these disciplines working together. We should learn how to work. So towards that, we started creating this idea called process. It has some good primary well-known processes: systems analysis and design, requirements analysis. By saying so, I'm not indicating that we should have 5-year software engineering programs. We should have 10-year software design programs. That is not the intention. The primary processes are in place. We have done a fantastic job in assuring that these ideas are taught well. The teaching learning has stabilized. People are able to perform system analysis and design, requirements analysis, software design, implementation, all in a short span of 4 decades. No other engineering discipline has blossomed that fast like software engineering has. System integration and testing, maintenance. These primary processes are our bread and butter as of now, today. So we are talking about how to integrate that with organizational process, how to integrate with supporting process, because everything is moving into adaptive complex systems at the higher levels, not merely at the transport level. There were days when I was telling very confidently that I am writing an application. The rest of the story is taken care by ISO OSI protocol, the networking protocol, which is not my job. It is the job of somebody else. Today, that luxury has vanished. You, as an application developer, is expected to know everything starting from domain name server and how is it impacting your application. So therefore, we started defining more processes. Any person must have been working in a domain for a minimum of 10 years in order to achieve international recognition. This is what is called 10-year rule. Understanding Creativity, Scottsdale, Great Potential Press. Read this book. It's called a 10-year rule. It's a rule which is known everywhere. From any domain, unless somebody is showing 10 years of experience, they are not likely to achieve recognition or called experts. It's a very good idea which was introduced by Steve McConnell. Microsoft Press 1998, Survival Guide. It took effect by 2010. By 2010, all the ideas which Steve McConnell has introduced, customers' bill of rights, project teams' bill of rights, it is no more happening in a way there where we tell that we have come to this agreement, we will go ahead with that. It is now the customer's right to demand why software went wrong. It is the project team's right to demand what happened in the customer side or in our own development team. It's not that we ended up like this. Please rank this project as somewhere in the high percentile, 25% success rate projects. 36 is the maximum. We fall into the next band, third band, roughly successful. We fall into the category of 20% success. So such things are no more acceptable because by default we understand software is not only impacting the quality of life but also the life itself. People are participating in meetings, Zoom meetings late into the night. We don't know what exactly is the concern that they will face and from the context where they are working. So please understand that today we have customers bill of rights to set objectives of the project and have them followed, to know how long the software project will take and how much it will cost. We have been finding all this difficult. We keep telling that we have been guesstimating, we will estimate. Today, on all requirements, we are expected to give a plan of action, a delivery, a timeline. It is absolutely essential. From 2020 onwards, people are going to become very stringent because the economy which is driven by software has gone down. The first half of 2020 is a washout. People will become very demanding because they are the case. They are the people who have put their lives online to be apprised regularly of risks. What is the risk? It's an appraisal that the team has to give. This is the risk component. A lot of demands are there. Similarly, project teams demands. We are now no more telling that change is all that we will permit. We do have the luxury of telling that I have a right to tell that this change is not acceptable. I happen to be the fellow who is leading this project. I am the developer. Whatever happens because of these n reasons, this change is not acceptable. Otherwise, till recently, we never had a luxury to say no to a change request because that's the way to please the customer. We are already delaying, over time, over budget, lot of defects. Every 1 out of 7 lines is defective. So we brought it into the bill of rights saying that for these reasons, this particular change cannot be accepted. This change will cost time. This change will cost more money. Previously, we were accepting change requests as gratis to please the customer, to please the stakeholders. Now all that will vanish. So next 10 years, the entire field of software engineering is doing something like this. We need more people as the system complexity increases. This is the corner: individual knowledge, judgment, and experience. Risk is increasing, technical risk, cost, schedule risk. As the system complexity increases, we need to bring in more and more people. Anywhere where you are bringing people, all the things that I have said in the last 21 slides is valid. It's very, very important. We need to understand how to bring people. So there are a host of process improvements. It's an adaptation based on ISO 12207. There is an echo. What's happening? Am I audible?
Yes, sir. It's okay now.
Okay.
Please adjust your laptop a little bit to view your face.
So please look at all the experiences that you are having very calmly. This is a work environment. The human has to adapt, and safety is best assured by humans. The machines will have a runaway condition. So we need to understand that the improved process definitions will have primary life cycle process, which we have been drilling at undergrad level, postgrad level. Most software engineering courses, programs have been drilling primary life cycle process. Now we have to talk about organizational life cycle process, supporting life cycle process. There are so many areas which we have to talk about: knowledge management, defect detection, test management. Essence of it is its life. It's life or line. That's the concern. Increased diversity, in our workforce and customers. So I will repeat what Goss said. I have had my results for a long time, but I do not yet know how I am to arrive at them. So, what is the context? We have been happy in the context free world. The context is this meeting. Reflect on this meeting, last 45 minutes. What are the experiences that you have had listening to this lecture? Then you will understand everything. Team distribution, there's a governance, there's a rate of change, age of the system. Systems are squeaking. We have legacy systems in the loop, the size, the criticality, business model, environment conditions, context attributes, good practices. The business domain now is defined as size of the system, criticality, age of system, rate of change, business model, stable architecture, team distribution, and governance. By using this slide, I am not imploring all of you to talk about object-oriented analysis and design. At this grade of complexity, for the kind of applications we are talking, object-oriented appears to be a very good paradigm even today. 20 years, we have been saying that the grade of complexity which we are talking, tomorrow better technologies may come. There are other 6 or 7 paradigms, but then this paradigm is fitting the context right now, the kind of applications that we are talking. Maybe with the AI and ML people becoming strong, emerging stronger, we will have the list processing paradigm, that's the functional programming paradigm, logic programming paradigm happening, distributed computing, concurrent programming. Wherever we go, we are talking about objects or things. Thing is more abstract than an object. So Internet of Things, as of now, in the current context of development, we strongly believe that object-oriented analysis and design may be a better bet, may be a better paradigm. Then what is this knowledge which we are talking about? Are there ways and means? Arguments do not end. There is nothing like, software engineering, curriculum engineering. There is software engineering. Like what we have been doing, program engineering, software engineering. From program engineering to software engineering was taking about 10 years. We were doing good programs. From there to software engineering, as I said in the beginning of my lecture. So there's nothing called curriculum engineering. But then what we need to understand very carefully is that it is high time that we have identified what is called knowledge management. The world will have to shift towards knowledge workers. And how do we identify knowledge workers here based on whatever I said so far? Can we have people who have 10 years of experience in every domain that is impacting this development today? Difficult. Very difficult. We need to recognize prior learning. Therefore, what is the way in which we can find out who are the knowledge workers? I know I'm having about 5 minutes more. So let's look at this. The exercise happened, it started in early 2000. Today we are talking about software engineering, body of knowledge, and SWBOC it is called in colloquial terms. Now it is version 3.0. Version 4.0 was to start early this year, but then because of the global pandemic crisis, it's getting delayed. 3.0 has 15 knowledge areas. So I can identify that you are a knowledge worker in the current day of software engineering if you have cleared a good majority of these areas. A globally recognized certification transforms programmers into software engineers. That is a transformation which was planned in 68, 69, but it is taking shape only now. 20 years, 30 years of rich, hard experience is telling us that we need to transform programmers into software engineers. For that, the primary life cycle is good, but then we need to have organizational life cycles. We need to have supporting services life cycles or supporting processes, all that coming together. That notion of integration is proving to be elusive. And unless we do that, we are not likely to blossom as product makers or even project leaders. E-learning, SWBOC standards are being adopted in corporates worldwide. Earlier on, I was lucky to participate in one more identification of knowledge area along with SWBOC. It was running parallel. When you are contributing at the level of IEEE, it's an IEEE exercise. You should also know how to do some good literature survey, what has happened before, what is likely to happen in future. So in the process of literature survey, I took care of this exercise called SEEK, knowledge areas. they have identified software evolution. They were seeking knowledge workers. How to identify somebody who is called a knowledge worker in the area of software engineering very soon. So software evolution, software process, they are comparable. So we found that Swebok has taken, this was the best at that time. Seek knowledge areas were the best. Certain things we are not able to map. There is something called what Seek called professional practice is something from a different domain. The idea, the term professional practice came from what is called Seek knowledge area. I'm a teacher of this particular course and I'm not biasing everybody, neither I am taking sides. The fact remains that the Seek knowledge areas were very dominant at a time when I was working on Swebok version 3.0 in the making. I had the fortune of comparing, making some comparisons to establish Swebok knowledge areas. And what we have been contemplating is professional practice cannot be away from the knowledge areas. It should be blended, integrated. So we are talking about green lines connecting similar case, blue lines indicating distributed relationships. There is no escape. We are likely to work with broken systems. We will have to talk about designing distributed applications in that context. There is no excuse now. Things have changed. Over the last 3 decades, all the things that I have been talking are very, very valid and relevant. So there are certain differences. So we have been talking about a methodology which is necessary to understand what is this software engineering body of knowledge. If you are good in 15 knowledge areas, you are a knowledge worker. You don't have to get multiple PhDs, one in computing, one in electrical, one in mechanical to do the software engineering that is necessary tomorrow. Multidisciplinarity, interdisciplinarity, everything is correct. We are talking about multiple engineering disciplines coming together. What is the assurance that you, as a software engineering degree holder, will perform in the next 20 years? We think that these knowledge areas are a better approach. Essentially, coming to the last slide, another couple of minutes on hand, another 1 minute on my machine, 2 minutes on my regular watch, 1 minute on my machine clock. Abstraction, coupling and cohesion, decomposition and modularization, encapsulation and information hiding, separation of interface and implementation, sufficiency, completeness, primitiveness, separation of concerns. The good news is all these 20 years we have been talking about this in different subjects, different programs, BE, ME, PhD. These are common. You don't have to worry about it. The essence of what we have been talking in our existing software curriculum are all there, they are retained. Abstraction, coupling and cohesion, decomposition, encapsulation, separation of interface, sufficiency, completeness and primitiveness, separation of concerns. What is the new thing? We need to put people first. Earlier on, business requirements, technology, quality and people was the order. People were at the last in all our ways of working in the last 2 decades. Now what are we supposed to do? In the middle, what has happened? Technology took the cake for some time. Then towards end of 90s and early 2000, quality became the number one. Nothing else was spoken. The sequencing, business requirements, technology, quality and people is now appearing as people, business requirements, and above all this is still quality, but quality of people first. We need knowledge workers. People should be like that. We want more people to come in, project, product, and process. The process definition is likely to have more and more people integration in software development rather than look at the first way of working, push everything into the machine and hope for the best. It's not likely to be there. People are essential. Systems fail. If anything can fail, it will fail. Systems will fail, but that is what is the challenge. The challenge for all of you in this webinar is that we need to understand that we work with fallacies. We are no more seeking fallacies as excuses. We have to fight on fallacies. They are there. Whether we like it or not, they are there. And under these fallacies, we should make things work, make things provable, and that's the concern. And with that, I would stop. The great news, the good news is all the things that we are doing in the regular curriculum life cycle, primary processes are intact. All of them are holding good. All nice technologies are still holding good. What is it that we are seeking? People first. And that has been difficult in our field, particularly because we began by progressing closer and closer and closer to the machine. The more closer we get to the machine, the more we think we have done the job. Now we have to bring many things closer and closer and closer to the people. People first, projects, product, and process. We are likely to hear only 4 P's. In this process, it's all quality, and that's how we become software developers. Thank you very much. I went by my watch, not the machine watch.
Thank you, sir. Thank you very much. Now the question session. Vinita, you can ask. Any questions available there?
Thank you so much, sir. It was really a wonderful and informative session on software development and distributed system. We have a couple of questions from the chat box, sir.
Yes.
What are the critical issues in designing distributed applications? I repeat, sir, what are the critical issues in designing distributed applications?
Number one is interoperability. We are facing heterogeneity. There is no second opinion about it. No two machines are the same. And unless we make these two distinctly different machines talk to one another, there is no progress. No two domains are the same. Unless we know how to make these two domains talk together, we will not progress. No two stakeholders are the same. Unless we know how to make them talk together, there is no progress. Interoperability at the machine level, at the domain level, at the stakeholder level. It is absolutely essential. We are not likely to unify all of them. That was a good attempt. We tried to unify all of them. Now we are talking about interoperability. The second one is elasticity. It is not that we start with 20 people and go to 150. We should know how to start with one person, next 1 minute, 1 million. That is what is being called elasticity. What we experienced in the beginning of this particular lecture is a scalability which was good. It's a good scalability. It shows your network. It shows the commitment. It shows a lot of things, people commitment. So from 20 to 140 was scalability. Now imagine from 20 to, let's say, 2 lakhs. That is elasticity. Interoperability and elasticity are my top two to talk about on this question.
Thank you so much, sir. The next question is, how can distributed computing help large software teams to be productive and organized? I repeat, sir, how
Yes,
can
I
distributed...
got the question.
Yeah,
got the question. In the entire field of IT, productivity is a paradox. It's very, very difficult to define what is productivity in our field. We have been hoping all along that we'll have some stand. Let's say, for example, to give you a concrete example, if you are writing in your profile that you are proficient in C programming, what is the acceptable productivity metric? In a given 8-hour working day, you should produce 60 lines of code. The metric may be crude. You may always challenge me that what is this line of C code? But then the standard, Capers Jones has come up with a wonderful report. There are so many nice organizations, very reputed, McKinsey is there, very reputed organizations indicating that if somebody is writing today in their profile that they are proficient in C programming, the expectation is in an 8-hour working day, they should develop 60 LOC. It is not that machinizable. We need to get an idea. We need to get an expression. It's not natural language. All these difficulties we have been talking. Therefore, we go back to that same question. Please learn computing first. That is the only way in which you can increase productivity. Not languages, not proliferation of languages, not proliferation of platforms. Computing as a fundamental idea should be understood much more. That is the secret for productivity. C is 60 languages. COBOL is 60 lines of code, I'm sorry. EDA is 10 lines of code. COBOL is 150 lines of code in a given day. Can we produce like that in a given week? So these are certain difficulties. It's a paradox. Productivity is paradox. And today we think that the only way in which we can show productivity is first learn computing, then learn to use existing pieces of code. Not necessarily as a complete component, but open code segments are there. That's what I said. They are great code bases. Please see how the existing code bases can come together. So one way of increasing productivity across global teams, you don't have to see each other. You can be anywhere. Online support tools, essential to understand that it is the in thing now, computer supported collaborative work. CSCW is the essence. So please focus on computing, the foundations. Please focus on using existing code bases. Please focus on computer supported collaborative work and the tools associated. Your productivity will increase. Otherwise, it's still a paradox. We have to still challenge ourselves.
Thank you so much, sir. Next question is, sir, how the distributed applications play a major role in cloud computing?
Cloud computing is service oriented. The point is, if you can tell precisely what is it that you are expecting, life is simple. Most of the time when we talk about distributed applications, our context is we are not too sure what we are really wanting. The cloud computing is a good idea. It ensures that all of us focus on what do you want the platform to do first. Are you clear? Can you tell me precisely what you want this platform to do? What you want this infrastructure to do? What you want this software to do? Otherwise, we go back, tell the same thing that requirements is the number one villain in the software development. 70% of the requirements always change. You are divinely blessed if 30% of the requirements are stable. That's what we have been telling all along. Now, what is the importance of cloud computing? It is forcing all the stakeholders, all domains, all the people who are talking about what is called the heterogeneity, answer that simple question. Please tell what is the expectation from this platform, infrastructure, what is the expectation, software, what is the expectation. If you can tell me this, I will write as services. It's a good service oriented architecture, which is why it is succeeding. At least those 30% of things which we want to do with cloud computing will become crystal clear. If it does this, if it is as per the agreement, it is done. The job is done. Otherwise, we are talking about a project mode. We once again get back to requirements, keep complaining that 70% are changing. What do we do? We have to bring in the idea of what I said, customers' bill of rights, developers' bill of rights, which are nicely reflected in cloud computing. The customer has a right to demand, the developer has a right to ask, saying that this is all can be done. Good service level agreements, they are reflected very nicely. It's a good progress. I hope I made it clear. We are now no more vague about what we want to do. 70% will change. What can we do? 30% if they are stable, it is great. We are very clear from platform, from infrastructure, from software. These are the expected services. And this is the agreement. The customer has a right to demand. The developer has a right to demand. Hope it clear.
Thank you so much, sir. Dear participants, any more queries?
I think that's all. There is no more questions. We can queries. We can go
Thank
for
you,
vote of
sir.
thanks.
Yes, sir. Dear
Thank you so much,
participants, the
sir.
feedback link for today's session has been posted in the chat box. Participants are requested to provide your valuable feedback through it. Now, I would like to invite Ms. K. Varlakshmi, Head of the Department of Computer Science and Engineering, to deliver the formal vote of thanks.
Good afternoon to all. It is a great honor to propose the vote of thanks at this occasion. First, I would like to thank our respected chief guest, Dr. T.V. Gopal sir, Professor, Department of Computer Science and Engineering, Anna University, for gracing today's session. On behalf of Perry Institute of Technology, Department of Computer Science and Engineering, we are very much thankful to you, sir, for sparing your valuable time for the technical webinar and the topic Fresh Software Outcomes in the Design of Distributed Applications. A language which is used for communication, but here it is a language which has been seen in different terms, and we understand clearly how the distributed system works, and the nature of the software. As your speech inspired, we are the computer engineers. We should know the complexity in solving the problems and make the system stabilized. It was a nice guidelines to design a software without failure. It was a really informative session, sir. Thank you so much, sir. I would like to express my profound gratitude to our Honorable Chairman, Mr. Saravanan Periyasamy sir, and COO, Mr. Sasi Virarajan sir, for giving us this platform. I extend my gratitude to our respected principal, Sir Dr. R. Paulson Kennedy, for his motivation and guidance. I would like to thank our respected Vice Principal, Sir Mr. B. Magesh, for his continuous encouragement and support. Of course, I would like to thank all the participants for attending today's session, and I express my thanks to all the CSE faculty members for their support. Thank you all. Thank you, sir. Thanks for once again for sparing your valuable time with us, sir. It was very informative session. Thank you so much, sir.
Thank you, ma'am.
Thank you. Thanks a
Thank
lot.
you. Thank you so
Thank you
much,
so
sir.
much, sir.
It was really wonderful and useful session, sir. Thank you so much.
Thank you very much. Thanks.
Thanks.
A good event never ends in the world, and they take only a pass and keep us waiting for the next. The day 2 session will begin tomorrow at 11 a.m. I request the participants to join the session on time as you did today. Meet you all tomorrow. Have a nice day. Thank you.
Yes, ma'am. Thank you, ma'am.
Thank you so much.
Thank you all. Thank you.
Thank
Thank
you,
you so much.
participants.
Thank you.
Thank you, sir.